Dear students, today I have taken one of the important exercise 3.4, and this is a question number 16. By this question I want to show that how to find the inverse by the elementary transformation. Actually, one of the candidate of your class asked me, sir, how we can find the inverse by the elementary operations. So that's why I'm going to explain this question here. Okay, now see this question very carefully. Suppose here you have to given A is equal to this matrix, and if you want to find the inverse of this matrix by a elementary transformation, actually if you want to find the inverse, there are the three methods. One of the method is a elementary transformation, second is a by determinant method that you will see in the second chapter. I think you have seen that one, and the third one is by operating A inverse on the both side. Then here I am going to solve this by elementary operations. So if A is equal to I into A, that means both the sides are equal, that means A is equal to I into A. Here I means identity matrix, and if order of A is equal to 3 by 3, so definitely identity matrix that has order 3 by 3. So that's why we have if we want to apply the row operations, mind it please, if we want to apply the row operations, in that case you have to write down it is equal to A is equal to I into A. Done. But if you want to apply the column operations, in that case you have to write down A is equal to A into I. Instead of I into A, you have to write down it is A into I. Then here I am going to apply the row operations, so that's why I have taken I into A. Done. So A, that means this is a matrix, is equal to this is equal to identity matrix, that means its order is a 3 by 3, so that's why it's a 1 0 0 0 1 0 and 0 0 1, and A will be equal to same matrix. Done. Now after this I want to make this matrix as a identity matrix, and this will be some unknown matrix, and A that will be a same. The logic is, because if it becomes a identity matrix and it is some unknown and it is a same matrix, then that means A into B is equal to I. That means B is nothing, that is called your inverse. I am giving I am going to solve this by one of the examples. See, suppose if you have to given it's a 2 into something, and if it gives the answer is equal to 1, so something is nothing but that is equal to inverse of this number. So that's why we are going to solve this one by this. We want to show that this one is identity matrix and this is just some unknown. After that, that becomes a inverse of this matrix. Okay, now the question is how we can make this is a identity matrix. See, here it is a -3 and it is a 0, and in the identity matrix it is a 0 and then it's a 1 and it's a 0, then it is a 0 0 and 1. So always try to make it is a 0, this -3 0, that means in the second row first column, and this is a third row first column. So always try to make these numbers always 0. Okay, that means you have to make it is a row equivalent form. Row equivalent form, that means row by rows you have to increase your zeros, because if it is a 0 and it is a 0 and it is a 0, when we add these numbers in the second row or first row, that uh, that never make your question as a wrong. So that's why we have to make these numbers as a 0 zeros. Done. So now see how we can make -3 as a 0. So that's why we have to add a 3 in the row number 1. We have to multiply row number 1 by a 3, and then we have to add in a row number 2. Similarly, we have to multiply row number 1 by 2 and -2, and then we have to add into the row number 3, so that it becomes a 0. So in this way we make it is equal to 0 by multiplying this. When it is multiplied by plus 3, then it becomes a 0 when we add this 0. 3 3 is a 9 and 3 2 is a -6, -6 minus 5, that's a -11, and similarly for the others, and same operation will be on the right hand side also. Okay, it is a 1 0 0, and when we multiply by 3, then adding in this, that becomes a 3, then it is equal to 3 1 0, and similarly it is last in the -2 0 and 1. Mind it, we have to apply these operations on the both of the side. When its order is a 3 by 3, in that case you can take 2 by 2 order. Done. Now when it becomes a 0 and 0, after this we have to make it is equal to your 1 and this element as is equal to 0. Okay, so that's why we are going to multiply row number 3, that means this element by a mine plus 3, so that when we add it into this, that becomes a 0, and when we multiply this by 8, then it, in that case, it becomes a minus 8. Minus 8 plus 9, that gives answer is equal to your 1. So that's why I am taking these operations, r1 plus 3 r3 and r2 plus r3. Done. So after this it becomes a 1 0 and 10 0 1 21 0 minus 1 and 4. Okay, when we apply these operations you will see, and same operations are here. When we multiply this one by r3 by a 3, so that means it's a minus 6. 3 to the minus 6. Okay, minus 6 plus 1, that gives a minus 5, and then 0, that is equal to same, and 3 was a 3. Similarly, when we multiply by 8, so it is equal to 8 to the minus 16. Minus 16 plus 3, that gives the minus 13, and same the other elements. Then after this I want to make this one is equal to 0, because we have to make identity matrix, and in the identity matrix it should be 0 0 and it's a 1. So that's why I'm going to add r3 and r2. So in that case it becomes a 0 0, 1 plus 1, that is a 0, 21, and this 21 plus 4, that is equal to 25, and similarly on the right hand side, that is equal to minus 13 minus 2, that's a minus 5, 1 plus 0, that's a this, and 8 plus 1, that is equal to 9. Done. Now see, it becomes a like this. Okay, now in the last, this is a 25. So now we have no chance to solve this one, so that's why we have to multiply this by a 125. I always avoid to multiply by the fractionals, because that makes your calculation is very typical, but in the last we have no option, so that's why we have to multiply by a like this number 1 by 25. Okay, so you also have to try like this. So when we multiply row number third by 1 by 25, that makes it's a 1, and when it becomes a 1, so in that case you make these two elements as a 0 0 very easily, so that's why I make this one is a 1. Then similarly on the right hand side we have to multiply row number third by a 1 by 25, minus 15 by 25, 1 by 25, and 9 by 25. Same here. Now here it is a 1, and I want to make this is equal to 0, so naturally we have to multiply minus 21, and then when we add it is equal to, it becomes a 0. When we multiply by minus 10, then it becomes a 0. Done. So that's why I'm going to apply the operation r1 minus 10 r3 and r2 minus 21 minus r3. After that you will see this is your identity matrix, and here it is your new matrix, and here it is your a, that is a same matrix. Done. So now you see a into b is equal to something, that a into b is equal to identity. Okay, so this b is nothing but that is called your a inverse. So in this method you can find the inverse of some matrix, and this is called your elementary transformation. Okay, thank you.